Hi, I'm Anita Srinivasan. Let's see some glossaries in digital electronics. This is the continuation of previous video. The first one, max term. Each individual term in canonical POS form is called max term. Next, Melee circuit. When the output of the sequential circuit depends on both the present state of flip-flop and on the input, the sequential circuit is referred to as a Melee circuit. Next, metastable state. It exists in the flip-flop if the output voltage is about halfway between a valid logic 1 voltage and a valid logic 0 voltage. Next, min term. Each individual term in canonical SOP form is called min term. Next, Mori circuit. When the output of the sequential circuit depends only on the present state of the flip-flop, the sequential circuit is referred to as a Mori circuit. Next, multiplexer. It is a digital switch. It allows digital information from several sources to be routed on a single output line. The basic multiplexer has several data input lines and a single output line. The selection of a particular input line is controlled by a set of selection lines. Next, NAND gate. The term NAND is a contraction of not and implies an AND function with a complemented output. When any of the input is low, the output will be high. Next, negative logic system. In binary logic, two voltage levels represent the two binary digits 1 and 0. If the lower voltage represents a 1 and the higher voltage represents 0, we have a negative logic system. Next, noise immunity. The noise immunity of a logic circuit refers to the circuit's ability to tolerate the noise without causing superior changes in the output voltage. Next, non-weighted codes. These are not assigned with any weight to each digital position. That is, each digit position within the number is not assigned fixed value. Next, NOR gate. The term NOR is a contraction of not or and implies an OR function with an inverted output. A low output occurs when any of its input is high. Next, NOT gate. The inverter performs a basic logic function called inversion or complementation. The inverter changes one logic level to its opposite level. Next, number system. The number system is a basic for counting various items. Next, numeric codes. Numeric codes are used to represent numbers. Next, octal number system. It uses first 8 digits of a decimal number system, that is from 0 to 7. As it uses 8 digits, its base is 8. Next one, octal to binary encoder. It has 8 inputs, one for each octal digit and 3 outputs that generate the corresponding binary code. Next one, OR gate. The OR gate performs logical addition, more commonly known as the OR function. The output is high when any of its input is high. Next, PAL. It contains OR array is fixed and AND array is programmable. Next one, parallel to serial converter. A parallel in series out, that is PISO. Shift register can be used to convert data in the parallel form to the serial form. Next, PLA. It contains both AND and OR arrays are programmable. Next, POS, product of sum. The product of sum is the expression which logically ANDs and logically OR literals. Next one, positive logic system. In binary logic, two voltage levels represents the two binary digits 1 and 0. If the higher of the two voltages represent a 1 and the lower voltage represent a 0, the system is called as positive logic system. Next, priority encoder. A priority encoder is an encoder circuit that includes the priority function. In priority encoder, if two or more inputs are equal to 1 at the same time, the input having the highest priority will take precedence. Next one, PROM. It is a programmable read-only memory. It allows user to store data or program. It contains AND array is fixed and OR array is programmable. Next one, propagation delay. A propagation delay is the time required to change the output after application of the input. Next one, propagation delay of gate. The propagation delay of a gate is basically the time interval between the application of an input pulse and the occurrence of the resulting output phase. Next one, propagation time. It is a time required to propagate the signal from the input of a logic circuit to the output of the circuit. Next, race around condition. It is important to note that in JK flip-flop, output is feedback to the input and therefore change in the output result change in the input. Due to this, in the positive half of the clock pulse, if J and K are both high, then output toggles continuously to the point A, B, C, D and E. This condition is known as race around condition. Next one, race condition. If there is a change in two state variables due to change in the input voltage, the difference in the delays may cause the one variable to change faster than the other. Such situations is referred to as a race condition. Next one, radix. Radix is also been known as a base. So it is the number of the character in the character set of a position number system. It is also known as a base. So decimal number have base of 10, whereas binary number have base of 2. Next one, reflective codes. A code is said to be reflective when the code for 9 is the complement for the code for 0, 8 for 1, 7 for 2, 6 for 3 and 5 for 4. Note that the 2421, 5211 and XS3 codes are reflective, whereas the 8421 code is not a reflective. Next one, register. It is a group of flip-flops used to store a word. A one flip-flop can store 1-bit information. So, an n-bit register has a group of n flip-flops and is capable of storing any binary information or numbers containing n bits. Next one, rise time. The time required to change the voltage level from 10% to 90% is known as rise time, and it is represented as TR. Next one, secondary variables. The present state and next state variables in asynchronous sequential circuit are called secondary variables. Next one, sequence detector. The desired sequence can be detected using a logic circuit called sequence detector. Next one, sequence generator. A sequential circuit which generates a prescribed sequence of bits in synchronism with the clock is referred to as a sequence generator. Next one, sequential codes. In sequential codes, each succeeding code in one binary number greater than its preceding code. Next one, serial to parallel converter. A serial in parallel out, that is SIPO shift register, can be used to convert the data in the serial form to the parallel form. Next one, setup time. It is the minimum time required to maintain a constant voltage level at the excitation input of the flip-flop. This device prior to the triggering edge of the clock pulse in order for the levels to be reliably clocked in the flip-flop. Next one, shift register counters. A shift register with the serial output connected back to the serial input is called shift register counter. Next one, shift register. The binary informations or data in a register can be moved from stage to stage within the register or into or out of the register upon application of clock pulses. Next one, SOP, that is sum of product. The SOP is the expression which logically ORs the logically ANDed literals. Next one, state diagram. It is a graphical representation of state changes that occurs in a sequential circuit. Next one, state equation. It is also known as the application equation. It is an algebraic expression that specifies the condition for a flip-flop state transition. The left side of the equation represents next state of the flip-flop, and the right side the Boolean function that specifies the present state conditions that makes the next state equal to 1. Next one, state machine. It is another name for the sequential circuit. Next, state reduction. It is a technique which basically avoids the redundant states, reducing the number of required flip-flops and logic gates to implement the sequential circuit. Next one, state table. For the design of the sequential counters, we have to represent the present states and the next states. The table which represents the relationship between the present state and next state is called state table. Next one, synchronous counter. When a counter is clocked such that each flip-flop in the counter is triggered at the same time, the counter is called synchronous counter. Next one, synchronous sequential circuits. In synchronous sequential circuits, signals can affect the memory element only at discrete instants of time. Next one, totem pole output. It is an output stage of TTL logic family. Next one, tri-state configuration. The tri-state configuration is a third type of TTL output configuration. It utilizes the high-speed operation of the totem pole arrangement while permitting output to be wired, ANDed and it is called tri-state TTL because it allows three possible output stages, that is high, low and high impedance. Next one, tri-state switch. It is a binary switch. It is closed when enabled and it is open in the high impedance state when disabled. Next one, turn on time. A delay between the application of high input voltage and the time that the collector currents taken to reaches 90% of its maximum value. This time is called the turn on time. Next, turn off time. The time required for the collector current to decreases from 0 to 0.1 when the output changes from high to low, it is called turn off time. Next one, universal gates. The NAND and NOR gates are known as universal gates since any logic function can be implemented using NAND or NOR gates. Next one, universal shift register. A register may operate in any of the modes like SISO, SIPO, PISO, PIPO or bidirectional. If a register can be operated in all the 5 possible ways, then it is known as a universal shift register. Next one, unsigned numbers. These number represents only the magnitudes. The last one, weighted codes. In weighted codes, each digit position of the number represents a specific weight. For example, in decimal number, if number is 567, then the weight of 5 is 100, the weight of 6 is 10, and the weight of 7 is 1. In weighted binary code, each digit has a weight 8, 4, 2 or 1. Thank you.